Hello everyone, welcome back to my tutorial. In this tutorial, we'll solve a plate with hole using plate with hole with force of 1000 Newton of material of steel we have taken. So we'll solve this problem using Code Aster. So first we'll create a geometry using Salome geometry model and we'll create a mesh. Then we'll solve using Code Aster and we'll get the displacement. So I have used a linear chord element. So this is the normal stress and this is the von Mises stress. Let's get started. Now, so I have saved the file here. Open the terminal. Use this command to open the Salome meca. Salome meca is the free and open source finite element software. Now just go to geometry. Now our geometry is a cube of length is 0.2. So this is actually missed. This one is 0.2 meter and this one is 0.1 meter. Now we'll create the model using Salome geometry. I'm going to use basic primitives box. So length is 0.2, width is 0.1 and thickness is 0.01. You can preview here by fit screen. You can see this is our model. Apply and close. Now just go to the geometry. I just want to create a cylinder. This is actually 2D view. Thickness you just considered 0.01 meter. So I just want to create a cylinder of diameter 0.05. Okay, at the mid of this plate. Now just go to geometry model. First just create one point at mid location. So this is 0.1 and this is 0.05. Just rotate and check. Yes, a point is created here. Apply and close. Now we just want to create a cylinder. Go to generation, primitives, cylinder. Now this only asks radius and height. Just go with this one. So now vector is z, OZ and radius is 0.025 and height is 0.01. Just have a look once. So this is my cylinder. Apply and close. Now I just want to remove the cylinder object from the plate. For that, go to operation, boolean, cut. So main object is plate, that means box. This one is cylinder. Deduct self interaction and apply and close. Now you can see, so this is the plate with hole. So now I have created the geometry. So this is my model. I'm just giving so only. Now I just want to create boundary conditions. That means groups. So here I just want to fix it. This is a fixed boundary condition. I'm just naming as a fix, F-I-X. Just apply. Here I'm going to apply force. Force and apply and close. Now I have created two boundary conditions, two groups. Now just save this file. Just click this one. Go to pictures. I'm just saving here. Now go to the mesh model. So this is my geometry. Now just go to mesh, create mesh. In this tutorial I'm going to create a tetra element. So for that, here you can see create all groups on the geometry. Whatever the groups we have created here, that will taken into the mesh. If you tick it, If you unclick it will not come. Now I'm going to create a tetra element using NetGen 1D, 2D, 3D. Now here there is a gear button, just click 3D parameter. Here you just specify the value of 0.002, 0.001. You can go with coarse, moderate, fine, very fine, custom also. So anything you just specify it, coarse, or I just manually edited these values. So just OK, apply and close. Compute. You can see I have created very fine mesh. Little coarse we can make it. So this will take more time to solve it. So edit mesh. This one. This is just make it 5. This is make it 3. Compute. So this mesh is enough for us. Now this is a linear tetra element. Okay, so just take this mesh for solving. So you can check here, our groups are came to mesh also. Now just export this mesh. Before it, just save it. Just export this mesh, export into MED format. So MED, same location, just save it. Now we have created the geometry and we have created the mesh. Then we have to create a command file for Code Aster. For that we will be using a software called Efficient V0 2.0. So this software you can download it from this software you can download from Moonies Engineering. Here you can go for software Efficient. So from that you can free to download this software. Okay, so now just right click this one, go for properties, make sure you have enabled the allow executive file as program, then close it, then right click it, open with OpenJDK Java 8 runtime. Now it will get open like this. Now we can create our setup. Go to analysis type. This is mechanical 3D. If any type you want to change it, you can change it. This is mechanical 3D only. Go to material. So carbon steel, you can name it. Material name is CS. So our units are in SI unit. So for that 210 e power 9, Young's modulus is 210 e power 9, Poisson ratio is 0.3 and density is 7860. Is assigned to all. Add it. Element type, we need not to specify any element type here because we are using 3D element. Go to boundary conditions. Here we are going to apply a mesh group to the boundary conditions. So boundary condition name is, we can give it as fix. Assign to, just go here, the name we have named it as fix. So go to here, so FIX, this is a yes, we can go for face imposed also. Fix 3 group is enough. So dx, dy, dz, this 3 is enough for 3D model. So add it. Now go to loads. Here we just want to apply force on the face. Here force. Now assign to, check with the group name of force. So this name and caps and small letters should be same. Now we just want to apply a force of, check with the model case, 1000 Newton to the face. So whatever here, this force on face is nothing but this will apply as a pressure. So whatever value we just want to specify it into an Fx, that has to be a pressure, Newton per meter square. So but in our case it is a force of 1000 Newton. Now divided by this cross sectional area. Here the cross sectional area is, so 0.1 is the height and thickness is 0.01 into 0.01. So the total area is 0.001. This is the area. So this area has to be divided with the 1000. So now we just go here. So the value is 1000 divided by 0.001. So this is the force of 1000 Newton, because this command will apply as a pressure only. For that only we are applying this one. Okay, so remaining things you just keep it empty, just add it. Now go to output, add this all the things, add all, save it as static.com command file. Now I have written the command file, just exit it. So now we have generated the command file. Now we just want to solve the command file using Code Aster. Now go to tools, plugins, here Code Aster, run ASTK. So this is the ASTK module. So just go to here, choose the location where we have saved our case. So pictures, Code Aster, fifth one. Okay. Now this much input files we required. So first one is command file, second one is mail. Mail means mesh. Third one is message, result, error, and post processing result file. Okay. Now just go to the location where we have saved. Pictures, Code Aster, we have. Keep it aside. So now our mesh file, our command file is static.com, static.com, and mesh is mesh_1.med. These things we can name it ourselves, message.mess, resu.rusu, error.err. Then we can write it as result1.rmed. Now we have set up the case. Now here we can specify the memory, how much we want to use it for solving this particular case. So I'm just taking 2 GB 2048 MB. So 15 minutes is just 1 minute is enough to solve this problem. This is very simple problem. So I'm just giving 15 minutes. I'm just keeping same. So interactive follow up. Then we can run it. Before running it, it will ask us to save. So just save this file. So I just saving it as ASTK save. Now I have saved it. Then we just run it. Now we can check the message file first. Just right click this message file. Just drop down here. Here you can see diagnostic job is okay. That means that there is no error. Our case is solved very nicely. Now just close this. Now you can check the result file. So this is the result file. So now just go to Salome FEA, go to Paravis. So right click this building. So go to Vengat, pictures, Code Aster. Okay. Then apply it. Now go to displacement. So this is the displacement plot. So to view in the blue and red red color. So you just go here rainbow, blue to red, apply, close. Again just drop it here. This value make it 12. This is a displacement. This is displacement x. Similarly, go to, I just want to see sigma, that means directional stresses. For that also, just go to change the color into rainbow, blue to red, and make it this value into 12. So just you can keep it here. So this is sigma xx. Now you can check the value. Here the cross-sectional area, whatever the cross-sectional area, here is the stress has to be whatever we have applied it, because it will apply as a pressure only. So here we have applied 1 e power 6, the same value we are getting, but you check the stress here, it's 3 times more. So 3 to 4 times more. So that is because of stress concentration around the world. Now go to 1 mesos stress. So change into 1 mesos, because this is steel material, it's a ductile material, that's why we are checking with the 1 mesos stress. Now just go to rainbow, blue to red, apply, close. Now here change this into 12. This is the 1 mesos stress. To see the deformation, go to displacement. There is an option called wrap by vector. Just click this one. Then make it some 50% of scaling. So this is the deformed shape of the model. To animate it, right click this one, create a new animation, just give OK. You can make it some frames of 20 frames, give OK. Now we can animate it. So this is the way it will get animated. To make it loop, just play it. So in this we have solved and checked the result. So with the Code Aster solver and ParaView. Thank you for watching my videos. Please subscribe my channel for more videos. It will encourage me to put more videos. Thank you.